going to apply now, okay, is equal to stress x px over a, because it's eccentric, right? Then we have plus my over iyy multiplied by z minus mz over izz multiplied by y. Okay. So some of you ask me, Eugene, how come you can always remember mz is the negative one? Okay, it's simple. I'll tell you why. If you look at the axis now, okay, if you look at axis, so if I view the axis from this way, if I take the view from here, right, this is y and this is what? Z. So we usually know going up is positive, yes or no? So that's why this is moment, but y is positive. And it's going towards the left, z is going towards the left is negative, that's why this is negative. So that's how I remember. Okay, normally when we draw an axis, we usually call this our positive direction going towards the right, positive direction going up, right? So if you look at the z is going towards the left, so that's how I remember it. Okay, no big secret. Okay, my memory is so bad. Yours is better than mine, I'll tell you that. Okay, so now looking at here now, px over here, a, this is due to the axle loading, and both of them are due to moment, bending moment. And when we call it unsymmetrical, it's because of what? Now we have two moment vectors, not one, we have two. That's why when you see two moments, when you see mz, my, and mz are not equal to 0, both of them, then we classify unsymmetrical loading. Okay, right. So that's all the theory. Okay, so we are going to do one example. Okay, that's all for the theory. It's really straightforward. Okay, so now we look at another example. Okay, we look at, I'm going to take this one. Right. I could not remember which example is this already. So the one we have done before is our example number 1. Okay, example number 2. Okay, so example number 2, we are going to put in together what we learned in week 1 and what we learned together. We're going to put everything together. Okay, and we are going to go from there. Okay, so for the load shown, okay, so we have 3 axle load. Okay, at point E we have 150, point H 500, point G we have 250. Determine the stresses at point A, okay, and point B, and the points where the neutral axis intersects the line ABD. Okay, so we have to find where the neutral axis intersects the line ABD. Okay, right. So we are going to draw our axis. Okay, so this problem did not have axis, so we're going to draw our axis. Okay, so I'm going to call this our x. Okay, move your cheeky salt. So this is our x, and then a vertical. Now remember, whenever you do any calculation, okay, you have to tell the audience where your axes are or what orientation are you looking at. Without all these axes, you're in a bit of trouble. Okay, so this is my z. Okay, so let me put in a place that is easier to see. Okay, this is how I'm going to orientate my axis. Okay, So the next thing we're going to do, we know that this is eccentric. Okay, so this is classified under eccentric. Unsymmetrical loading. Okay, so immediately declare the formula that we're going to use. So we know that stress X is equal to Px over A plus by My over Iyy. What I say and what I write is different. Yy multiplied by Z minus by Mz over Izz multiplied by Y. Okay. So the first thing we have to find what is our Px. Okay. So our Px, they are all in tensile. You can see that 150 is pulling away from the block, 500 is pulling away, 250 is pulling away. So Px is equal to 150 plus by 500 plus by 250. Okay, so this will be equal to 150 plus by 500 plus by 250. So it's 900 pounds. Yeah, do it again. 150 plus 500 plus 250, 900 pounds. Okay, so Px, so the area is equal to, so you have 4 inch multiplied by 1.8. Okay, so 4 times by 1.8 is equal to 7.2 inches squared. Okay, so Px over A, you can directly write this down. Okay, is equal to 900 divided by 7.2. So it's equal to 125, 125 pound inch positive. Pound inch squared. Okay, or PSI. Okay, sorry. What am I doing? PSI. Okay, so it's 900. Let me do it again. 900. 4 times 1.8. 900 divided by, so it's 125 pound inch positive. Okay, so next we have to look for the moment, which is moment about Y and what is moment about Z. Okay, so the best thing to do for this is by looking at the front view. Okay, so we are going to look at I'm going to change we're going to look at Y and Z. Okay, so this is my Y and this is our Z. Okay, so we're going to look at the front. All right, so this is our point E. Okay, point H, point G, and point F. Okay, so my bad, sorry, I should have thought further. E, H, okay, G. Let me draw it further apart. Right, so now we know. Okay, I'm going to draw the load. Over here, you have a load coming towards us at 150 pounds. Over here, you have another load coming at 500 pounds. Right, over here, we have another load going at 250 pounds. Okay, so now we want to find the moment about y-axis. Okay, so my strong recommendation is you draw the y-axis. Okay, so this is your y-axis, and we know that the force multiplied by perpendicular distance. So write down the perpendicular distance. This is equal to 2 inch. This is equal to 2 inch. Okay, and I'm going to make an assumption that this direction, my moment about y is positive. Okay, I'm going to make the assumption. It's just assumption. Okay, if it's negative, you just need to flip it over. That's it. Okay, so now you declare positive is going in this direction, right? All right. So it's like a right hand rule, right? You grip. So you're going to take a summation about moment about the y-axis is equal to, so the 150 is going to be positive because it's going to be the same direction as the my positive. So it's 150 positive 150 multiplied by 2 plus the 500 is in the same direction, and then minus by the 250 multiplied by 2. Okay, so 150 plus 150 multiplied by 2 plus by 500 multiplied by 2 minus the 250 multiplied by 2 is equal to 800 pounds positive. So positive means the gas direction that we initially had is valid. It's correct. Okay, so it's correct means this is in positive. So once you have this, immediately declare this. Okay, immediately you declare it. Okay, this is going to be a compression. This is going to be in tensile. Okay, due to my. Okay, so I usually put my is going to be tension. My is going in this compression. Okay, so that is your my. So at the same time, you can also calculate Iyy. Right? You can also calculate I. So Iyy. So some of you are like, oh, shoot. How do I know what is Iyy? Which is your width and which is your depth? Yes or no? So not to worry, parallel to the axis. This is your width. Perpendicular to the axis. This is your depth. Simple. Right? So Iyy, the width is equal to 1.8. Right? The depth is equal to 4.0. Right? The depth, yep, that's depth divided by 12. So this will be equal to 1.8. That's a 4 power of 3 divided by 12. So it's equal to 9.6 inches to the 4. Let me do again. 4 power of 3 times by 1.8. Yep, 9.6. Okay, so that's done. Okay, so where are we now in our analysis? Okay, so we have done this, we have done this, okay, we have done this. We need to find what is our IZZ over IZZ, okay? And we also know what is the tensile and compression, okay? All right, where's our tensile? Okay, so next we'll do the same, okay, make things simple. Then same transformation. Right, this is Y and this is Z. Again, put this down. All right, draw this out. All right, so this is point E, point H, point G, and point F. All right, then you draw in your loads. Okay, so we have one here. This is going at 150 pounds. One here. The dot means it's coming towards us. Okay, 500 pounds. And then the dot here, this is 250 pounds. Okay, so now we will know we want to find our moment about Y or Z, sorry. Right, so this is our Z. So we're going to make an assumption using right hand rule. MZ positive is going this way. Okay, this is an assumption. You can go in the opposite direction. It's entirely up to you. Okay, and then once you get here, immediately declare your distance. Okay, a lot of times students get confused is because of this distance. So this is 0.9 inches over here. This is also equal to 0.9 inches. Okay, that's equal to. So from here, we can do the same thing again, right? So we know that we're going to calculate. We're going to assume MZ positive is in this direction, right? So MZ is good. So the 150 is going opposite. Okay, so minus 150 multiplied by 0.9. It's so critical to know your distance. If not, you multiply the wrong one, again, your answer will be wrong.